The 1997 A-level question, right? 1997 question. 1997 question. So it is very simple. That's why I explained what is meaning by the Doppler effect, because this is the first question, ever question given for Doppler's effect. So how would you demonstrate this effect using a ripple tank and given application of Doppler's effect? See how primary these questions are. So what is the meaning of Doppler's effect? Hmm? The change of frequency, the change of apparent frequency to a certain observer when there is a relative motion between the source and source of sound at the, it is not only for sound, but for a level we can just say like sound, source of wave actually, source of sound, uh, and the observer. Uh, the observer hears at increased or decreased. So we have to say like what? The change of apparent frequency of uh, apparent frequency. Give me 1 minute. Right? Change of apparent frequency of certain source of sound between the source and the, so due to relative motion between the source and the observer. You have to write that. How do you demonstrate this effect using a ripple tank? In the ripple tank, you know that when you just let certain wave to occur. So there are many methods. You can generate waves in using this type of vibrator, and also you can generate using this type of point vibrator. Using this point vibrator, it will just spread certain wave like this with even spacing. Right. This is the normal way. But if you just move this one forward, firstly your point is here. Next here, 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 you move the point. Now you can see the waves are getting closer to here and far away from the other. In this side getting closer, the other side getting away. Getting closer, getting away. So if you observe it from here, you can see the wavelength is kind of like reducing. Here the wavelength increasing. So demonstration can be done by this manner. Right. Given application of Doppler's effect. So you can apply this method in many ways, but the first one of the very important thing is use this method in identification of the speed of vehicles, like in police radar gun and sports radar gun to determine the speed of cricket ball like that. So Doppler radar guns, and also in uh, heartbeat of a fetus. Fetus can be the embryo inside the womb. So heartbeat you can use it, calculate using Doppler's method, and also speed of blood cells in the. Now sonic boom is a different case. Sonic boom is a different case. I have already explained you. Sonic boom has nothing to do with this one. It is not related to Doppler's effect. And the speed of blood cells inside the vessels, you can just transmit this type of wave with frequency F naught, and receiving frequency is double dash something. For these things, you can just write many examples. Now a boat is traveling at 18 kilometers per hour through a small cliff sounding horn at 335 hertz. The speed of sound in the air is 340 ms minus 1. Find the frequency of the horn heard by the boy on the cliff. Right. There is a certain boy here. He's waiting for that boat to come. Something, who knows? If not, this emits certain sound of F naught, which is moving at velocity of v source. Actually, the source. Here, the observer, the observer is zero. It's just waiting over there. The speed of sound is 340 ms minus 1. Right. So he hears a certain sound of F dash. So you can write like equation for F dash equals to. Now you have to consider one thing. Is that the kind of like what? Source moving or observer moving? I told you to write V for upper and bottom and in the numerator and denominator as well. Now consider who is the king. Uh, I told you observer is the king. Source is not the king. So it is the moving source. So you have to put that in the bottom with the minus sign to make it higher. When the denominator drops, the numerator increases. So F naught. So let me apply the values here. මේ දේවල් මම මේ කවුද බොස් කියන එක බලන්න කිව්වා නේද තියරි ක්ලාස් එකේදී 340 over 340 minus here the speed I have to convert here it is given in kilometers per hour 18 kilometers per hour to meters per second divide by 18 5 over 18 it is only 5 minus 5 times 335 hertz. Wow, excellent and fantastic. See, 340 over 345, 35 by 335. Apparent frequency is like F dash 340 hertz. Understand? Okay. Can you understand? Now it says an echo of the horn is produced by the clay. Find the frequency of the echo as heard by the man on the board. Now this part, this whole part, I'll just copy the same thing. But the thing is, now let me just enlarge this diagram and explain you. Here the thing is, this one was emitting certain sound in F mode. And the boy in the clip get the sound as F dash. So does the uh, what the clip also get the same sound as F dash. It is reflecting off as the secondary source. Now the once it reflects, it is act as if a secondary source. As a secondary source, it gives the sound back to the person in the board. In what way? F dash. He just the clip reflect the sound in the terms of F dash as the secondary source. Now this one, it is no longer observer, it is going to be X2 because the secondary source. Now the board was the sound source. Now it became a secondary, but observer, sorry, secondary observer. Okay, now the clip gives the sound reflected in F dash. He now as a secondary source observer moving towards the source. Now it is going to get another Doppler effect as the observer itself. Now it acts as if the observer F double dash is going to be what V and V. I told you it is like Bosch law of observer. V observer by F is F dash. Now it is F dash. I know what is F dash now. F double dash is going to be 340 plus 5 divided by 340 multiplied by 330. Sorry, 340 again. 340 and 340 cancel. So again, one more time. The answer of double dash becomes 300, 200, sorry, 345 hertz. Can you understand this procedure, everything? Yes or no? Yes or no? If the man hears the sound emitted by horn and the echo together, find the number of beats per second heard by. I told you beat frequency is like F2 minus F1. So F2 is like 345 minus 335. So it is going to be 10 hertz. Beats frequency is 10 hertz. If the boat now turns back and moves away from the cliff at the same speed, what is the frequency as echo heard by the man? Okay. Now he returns with velocity of v. Now as the burst of source moving away, the cliff gets it as f dash, return as f dash. He hears again like f double dash. Now for the first case, I can write it like f dash is equals to, for the other case, now you are going to, sorry, if not here. So sorry, the subtraction. I made a mistake. It's moving away. Thinking I'm going to substitute this value to here. My answer for double dash going to be V40 minus 5 over V40 plus 5 times V35. Okay. Let's use the calculator. Oh, shit, no. Calculator. V35 multiplied by 330. 5 and you are going to divide that by 345 and your answer is going to be 325 point. Nearly f double dash hertz is 325 hertz. Very simple, so elegant, so beautiful, very easy. Understand? Their mother got you the point. මේ ළමයි මේක ඉන්නවා සද්ද නැතුව. Okay. Shall we just try this question? 1995. That's a little bit different, difficult question than the previous one. Yeah, little bit difficult. So, are you trying to do this one at home? No, no. It's better to do this one because that one will take longer time. Because I want to explain something related to the eye and telescope. So we'd better try this one very quickly. This only will take like maximum 10 minutes. I will give you 10 minutes for trying this one. After that, let's go for, yeah, the eye question here. Let's maximally try to do this telescope. We have to do these questions very quickly. 10 minutes is maximum for this time for this question. 1994, very simple question. Only 10 minutes for you. Your timer starts now. Why does the refractive index vary from medium to medium? The reason is from medium to medium, the speed of light is different. So light travels as a what, wave front. So when the light hit the wave front hit the boundaries with two different speeds at different angles, so it will create some kind of bending in the interface. You have to interpret this with including all of these terms. ඒතකොට ඒක මම වචන ටික දාලා ඔයාලට දෙන්න පුළුවන් උත්තරේ. හරි කැතයිනේ ඔයාලා ලියන්න පුරුදු වෙන්නේ නැහැනේ. So I will only tell you the most important words and you will have to coin up with the answer. නැත්තම් spoon feed වෙනවා කටපාඩම් කරන්න වෙනවා. So I will tell you again what are the points, key points should be there. Marks will be given for the key points. Light travel as if a wave front. You have to include that term. And the speed of light is different from medium to medium. You have to include that. When light hit against two mediums separating with two different boundaries at an angle, it will just bend accordingly. You have to include those things. As shown in the figure, monochromatic ray. Monochromatic means only one in the spectrum. So it is like ending one is red. Beginning one is something like blue, but it is not actually blue. It is said what? Violet. Purple color type of thing. With your any of these color, imagine like yellow color from sodium blank. That's the most favorite color. Like that. So monochromatic light ray entering. In air is incident on the surface of the spherical water drop at A with an angle of incidence I. The ray is refracted into the water with refractive index, refractive angle R. The reaching to the opposite side of the drop at B, the ray is partly reflected back uh, and emerges into the air at C. Partial reflection. It is called partial reflection. Normally, it is not total internal reflection, right? You have to understand one thing. It is not total internal reflection. People really wind up with this because it is lower than the critical angle. This is not total internal reflection. I have to tell you, when certain ray like this, uh, just like hitting a certain surface, like in this manner, this one may refract and some part of that just reflect back. This is called partial reflection. It's called what? Partial, partially reflected ray. So it is not total internal reflection. No? Actually, this one will refract away. Definitely refract away like this. We are not talking about that part. We are only talking about partial reflection here. Partially reflect, comes to here, and again refract and moving out. That's what we have to consider. Reaching to the opposite side of B, the ray is partially reflected, but imagine what is the value of angle of emergence. Okay, guys, let me just enlarge this. It says this is the radius. If I extend that to, it will reach to the center. If I draw another line from here, what is that line? Again, R. If I extend another line from here, what is that line? Again, R. If the radius for R for radius, this one angle should be the refractive angle of R. This one should be R. See, this is, let me use different angle. The same way, it's called isosceles triangles. If this is x, this is x, this angle is theta, this angle again becomes theta. Okay, 10 mathematics. This is also R. This angle will also be R because isosceles triangles. Can you understand? Can you remember those? Ane? Say yes if you understood. අත්වා yes කියනකම් බලන්න කිව්වොත් මට මෙතනම නැති වෙන්න වෙන්නේ බලන්න. yes කියනකම් බලන්න. So if this angle is angle of reflection, the light has a weird way. It can just travel forward and backward with the same way. Huh. It is like reversing. If this one entering with R, reflect away with what is the angle it should be making here? That will be what? Ah, I. This angle will definitely be I. I hope you understood that. This is going to be emergent angle will be I. Very easy to understand that. Derive an expression for the total deviation of ray in terms of I and R. You have to have a super level of mathematics to understand this. Not too much and not too less even. ටිකක් ඕනෙත් නෑ. ටිකක් ඕනේ. Because it's okay, guys. R, R, R. R I I. Right. This light ray was just about to travel somewhere. This light was about to travel to somewhere like this. It was just happily about to move somewhere like this. But it didn't happen. Because why? It had to bend here. Now, what is this bending? We can do this in question in many multiple ways. Going to be I minus R, this remaining answer. Right. It was just happily about to move with that deviation. This is the deviation number one here. But it had to bend again to here. What is this total angle here? 180. Now this is going to be 180 minus 2R. What? This remaining angle is 2R. You can find out this bent angle. Deviation 2. Can you understand? Yes or no? This is 180 minus 2R. Simple mathematics. Huh? Simple year 10 geometry. Now again it comes to here. It was happily about to move here. But it doesn't let the then let. These are, this one is also R. Return to here with certain angle of here. Final deviation D3. What is this D3 again? I minus R. Okay, now let's see what are the total deviation. Deviation total is equals to D1 plus D2 plus D3, three different deviations. So what is the total deviation here? I minus R plus 180 minus 2R plus I minus R. So let's get the numbers here. One, I can get 180 for the forward, 180. So this one and this one going to add it together. Plus 2I minus how many R's? Minus R, minus 2R, minus R, minus 4R. Did you get this answer? Yes or no? Yes or no? උත්තරය ආවද? Actually, this should answer should come to this point. ආයෙ නැත්තම් නෑ කියන්නකෝ. If I equals to 30 degree and the ray is fully deviated by 156, calculate the refractive index of water for given color. Right. I have to find out the total deviation is given 156 equals to 180 plus 2i minus 4r. It's going to be like, I want to get this one back to here. 4r is equals to 180 plus 2 times 30 minus 156, 240 minus 156. Kasi 50 kasi 60ක් අඩු කරලා it's like 70, sorry, 84. Going to be 84 degrees for R. So R is equals to 84 divided by 4. R is equals to 21 degree. So now you have to find out the refractive index. You know the way to do it. I1 N1 sine I is equals to N2 sine R. Just substitute. Air, just N1 is air. Sine 30 is equals to N2, I don't know. Sine 21. N2 is equals to sine 30 over sine 21. So sine 30 is like 0.5. Sine 21 value, we have to find that in the calculators. So in the actually like in the logarithmic tables, not in logarithmic tables, sorry, sine tables. But I'll just find that in the calculator for myself. Sine 21 will be 0.3583. We will get the refractive index as 0.34. Sorry, 0. Sorry, 1.40. 1.40. Can you understand the way how I did it? Now asking, can the ray suffer total internal reflection at the opposite side for some values of I? Justify your answer. I have to find out the critical angle. So we know n equals to 1 over sine c. C equals to 1 over n times sine inverse. Now we know 1.4 sine inverse. So let me find out critical angle first. Zero point 0.7142. This value is going to be 0.7142 sine inverse. I have to find that in the sine table to find out the sine inverse, but I'm just going to do it in calculator here. Sine inverse 0.7142 is going to be 45 degree and 34. minutes. Okay. Now it says for any angle will it create this critical angle. To create the critical angle, it should come up with what? A parallel perpendicular to the surface, then only it will reflect here with the critical angle greater than here. Here the angles will be more than critical angle. So the smallest, this angle should be 45 degree. So you know that the in a triangle here, it is an isosceles triangle. This isosceles triangle, the radius is here. So this side should be what? Greater than 45. This side should be greater than 45. It won't happen accordingly. According to the trigonometry, if these two getting bigger than 45, it is no longer going to be what? Triangle. It's no longer going to be triangle. So it will never suffer total internal reflection. You have to say like in the opposite side, according to trigonometry, these two angles should be opposite sides isosceles. If this one is more than 45.31, this one also should be 45.31. Then the collective magnitude of the opposite angles is if it is more than 45, sorry, 90, this no longer going to be a triangle. It will just rip off this side and open it up. Open it up means you have to complete it using another side. Then it is no longer going to be a triangle. It's going to be a rectangle. So it will violate all the mathematical terms. So it will never create such an angle. If you saw this point, සමහරුන්ට අතනින් එහාට යන්න තේරෙන්නේ නැහැ. මොකද mathematics අවුල්නේ. So if the question is coming up with 4.7.5 marks, you will at least get 7 marks for this amount. Because why? You only couldn't explain this part. මේකත් කරගන්න පුළුවන් නම් මේක triangle එකක් නෙමෙයි කියන එක සමහරවිට එකපාරට තේරෙන්නේ නැහැ. Shall we try this one? වෙලාව ඉවරයිද? ගොඩක් වෙලාව ගිහින්. බලන්න වෙලාව කීයද කියලා. 12:21. So what is your suggestion? Shall we stop this right now? Shall we try this question? It's up to you because you have schools to go tomorrow. ඔයාලා කැමති නම් වැම්පයර් සීසන් එකක් කරන්න පුළුවන් ඉන්ස්ටෙන්ට් එක. එහෙම නැත්නම් දැන් ඉවර කරන්න පුළුවන්. ඔයාලා කැමති දෙයක් කරමු. කොහොමත් මේක එක්ස්ප්ලেইন කරලා ඉවර වෙද්දී ඊයේ ටයිම් එකයි another 40 minutes will require. I'll have to give you like 20 minutes. I will have to take like 20 minutes to explain. Whatever you decide, try this one at home or try this now. නැත්තම් මම එක්ස්ප්ලেইন කරගෙන දාන්න ඔයාලට කරන්න ටයිම් එක නැත්නම්. එහෙම නැත්නම් මම වීඩියෝ එකක් කරලා දාන්න දැන් ඔයාලා මතක් කරන්න ඕනේ. සර් අර ඉතින් ප්‍රශ්න ටිකට වීඩියෝ එකක් කරලා දාන්න. අන්න ඒතකොට මම කරන්නම්. දැන් 25 සෙට් එකේ නම් සෙනෙක් මලා එහෙම මතක් කරනවා. සර් කරලා දාන්නකෝ. දාන්නේ නැහැ නේ. මම ඉතින් කියනවා හරි හරි මම මතක් කරන්න. තුන්වෙනි පාරේ තමයි මතක් කරනවා. එතකොට මම වෙලාව සෙට් වෙනවා ෆ්‍රී ටයිම් එකකට. අන්න එතකොට කරනවා. හරිනේ. මොකද කියන්නේ දැන් කරනවද කැමැත්ත? කියන්න නම් මොකද්ද වෙන්න ඕනේ? වෙලාව දැන් මෙතන වෙලාව නාස්ති වෙන්නත් වෙන්නේ නේ. Whatever you feel like, we can do. අත්නික ෆින්ගර්ස් වලින් අල්ලන් ඉන්නේ නං හරියන්නේ නැහැ දුවන්න දුවන්න. මම මේ අත්නික ෆින්ගර්ස් වලින් අල්ලන් ඉන්නේ කියනවා මේ මොකද කියන්නේ ළමයි? ඔයාලා වැම්පයර් සීසන් එකට රෙඩිද? කැමති නම් තව ටික දවසක් ගිහිල්ලාම පටන් ගමු. අපි ස්කූල් යනවා නේ තාම. ඔයාලගේ ස්කූල් වදේ ඉවර වෙන්නේ කවදද? සමහර නම් දැන්ම ස්කූල් යන්නේ නැහැ. සමහර ඉතින් අන්තිම දවසේ වෙනකන් යනවා. කැමති නම් එක්සෑම් ලඟ වෙලා පොඩ්ඩක් අර පාන්දර 2-3 වෙනකන් යනවා. අර මේ වැම්පයර් සීසන් එකට යන්න පුළුවන්. එක්ස්ට්‍රා. නෑනේ මෙතන කට්ටිය රෙඩි නෑනේ. එහෙනම් අපි අදට වැඩේ ඉවරයක් කරමු. ඔයාලා සෙට් එකේ ඉන්න අරම ගානේ භාගයක් නින්න සෙට් එකෙන් භාගයක්වත් වැම්පයර් සීන් එක රෙඩි නම් අපි කරමු. කොහොමද තව මාසයක් විතර දෙකක් යන්න ඇරලා වැම්පයර්ලා එකෙක් හිටියත් මම ඌ අල්ලගෙන කරනවා. තව මාසයක් විතර කල් දෙනවා. ස්කූල් එක කියලා ඔහොම නැහින්ද බෑනේ. ටර්ම් ටෙස්ට් එක ලිව්වට පස්සේ ඉස්කෝලේ එන්න තරම් කන්ෆිඩන්ස් එකක් තියෙන්න try එකක් හදාගන්න. ඉතින් හරි ගියා කියලා ඌ වැඩක් වෙන්නේ නැහැ. හරි. වැඩි ඉවර කරමු. God bless you. Bye.
Thank you, sir.
හරි. bye boy.